All right, so I'm looking at 2.4, factoring polynomials. This is page 13 in the honors packet and page 7 in the Algebra 2 packet. When we talk about factoring, we're essentially trying to undo distribution. So if we look at our first problem here, simplify, it should be straightforward. We can distribute the 5x to both of those, and that'll give us 10x squared plus 20x. When we factor, we're trying to undo that problem. So we're essentially saying, instead of distributing to multiply something in, what is something we can pull out? And to do that, we want to look for our greatest common factor. So you can see that we have 3 and 6, so our greatest common factor is 3. And then both of these have an x, so that means we can also pull out an x. And so then what's left on the inside? Well, it would have to be x plus 2. We can do that either by dividing each of these by 3x, our common denominator, or we can also just see that 3x times x is going to give you 3x squared, and 3x times 2 is going to give you 6x. And that pairs with this step down here, how to factor out the GCF. Right, this is when we're factoring out one term, right? We're factoring out a monomial. We'll contrast that to factoring out a binomial in a minute. But when we're just trying to factor out a monomial, our first step is to identify the GCF of the polynomial. And to do that, we want to check the coefficients for GCF. So here we have 30, 9, and 6. And the GCF between those three is going to be 3. And next, you want to look at the variables. And it says, if a variable is present in all terms, take the one with the smallest exponent out. So we can look here and we can see that this has x to the fourth, this has x cubed, this has x squared. So each term has an x, which means we can take out the one with the smallest, right? We can't take out more than that because this one only has 2. And so now if we want to figure out what should go in the parentheses to make sure that when we distribute, we get back to this original equation, well, you can do that by dividing kind of 30x to the fourth by 3x squared, right? You can divide each of these by the term that we're pulling out, or you can just try and use your intuition and say, well, if that's 10x squared, that's minus 3x, and that's plus 2, then when we distribute, 3x squared times 10x squared is going to give us 30x to the fourth. 3x squared minus times negative 3x is going to give us negative 9x cubed, and 3x squared times positive 2 is going to give us plus x squared. So if you're doing the monomial case, right, where we're trying to pull out one term, you want to look for your GCF, pull out as many variables as you can, and then check your work through distribution. It's significantly more complicated when we're trying to factor out a binomial term, right? We're trying to pull something that looks like this, 2x plus 3, out of something that looks like this, for the result to be two things being multiplied together that are each binomials. So let's start by going forward, right? Let's start by distributing. And see here how we could just distribute the 5x there, and there, right? We could do it in one step. Here we have to do it in 2 steps. So we have to start by distributing the 2x to this entire second term and distributing the 3 also to this entire term. So what is that going to look like? It's going to look like 2x times the second term, x minus 5, plus 3 times x minus 5. And I'll highlight here so you guys can see it. This x minus 5 went there and there. And this 2x minus 3 got split between there and there. Right, we're taking the 2x minus 3 and we're multiplying the 2x by the second term, and then we're multiplying the 3 by the second term. After we've distributed once, we can go ahead and distribute again. right? This is why it's called double distributing, which it makes sense. We have to do it twice since we have two terms here versus just one up here. And so if you distribute again, well, 2x times x, that's going to be 2x squared. 2x minus 10, that's going to be minus 10x. 3 times x, that's going to be 3x. And then 3 times minus 5, that's going to be minus 15. And our final step is going to be to combine like terms. So we can combine these two in the middle here. And we can see that we're going to get 2x squared minus 10, minus 7x minus 15. All right, and so now if we're looking over here, we have a different problem, and we're going to try and undo this process, right? That's might be a daunting task, but let's take it piece by piece. So we're trying to undo this process to start with something that looks like this and end with something that will look like this. So the first step that we want to do here is to undo the last step we did over here. And if you remember, the last step was to combine like terms, to combine those two b terms to get the -7 here. So we want to do the same thing over here, where we want to take this 14x and we want to split it up into two different terms. This 8, right? We want to split this up into two separate terms, just like to undo the combination that we did over here. And you might be asking, what are those two terms that need to go in there, right? Like out of all of the numbers you could pick that add up to 14, how do you know which one you want to use? Well, this is why we have been practicing the magic X, right? This is where this comes in handy. Because essentially, the two numbers that you're going to choose are the two that are going to go left and right here, and they're going to multiply to A times C, right? You take this first number and you multiply it by this last number, 24, and they need to add to the middle term 14. Don't worry about understanding why that is the case for now. Just watch and see the magic happen, right? We call it the magic X for a reason. So now we want to look for two numbers that multiply to 24 and add to 14. And I'm going to say those two numbers can be 12 and 2. Right, so we have 12 times 2 is 24, 12 plus 2 is 14. Now we can take this 14x and let's break it up into 12x plus 2x. Right, so that was essentially this step here. We combine those two terms into this term. So now we're undoing that, right? We're taking this term and we're splitting it up into two separate terms. What was the next step, right? The next previous step, right? So we've gone from there to there now, we've undone that. Let's try undoing this. And what did we do to go from here to here? Well, we distributed through, right? We distributed the 2x to the x minus 5 and distributed the 3 to the x minus 5. So let's try and undo that. And let's think about trying to figure out what can we factor out of these first two pairwise and these second two pairwise, right? So we're looking at these two first, then these two, and we're going to try and factor out the greatest common factor just like we did up here. So if I'm looking at 3x squared and 12x, my greatest common factor is going to be 3x, right? The greatest common factor between the coefficients is 3, and they each have an x. And then what would I need to put in the parentheses to make sure that when I distribute, I get back to 3x squared? Well, I can divide 3x by, I can divide 3x squared by 3x, and I can divide 12x by 3x, or I can just see that if this is x plus 4, then 3x times x is going to give us 3x squared, and 3x times 4 is going to give us 12. looking at the second term, what's our GCF between 2 and 8? Well, that would be 2. And then what would need to be left in the parentheses? X plus 4. Right? Because if we distribute the 2 here, and we distribute the 2 here, then we're going to get 2x plus 8, right? 2x plus 8. And this is where the magic of the magic X shows itself. Because if you notice, this is the same as that, right? We chose the numbers 12 and 2 using the magic X, and because we chose those numbers, we get the exact same thing on this step. And so if we want to go back to undoing this final step, right, going from there to there, in that step, we took this first term and we broke it up into 2x and 3. So let's undo that by combining the 3x and the 2. And we can write that 3x plus 2 times x plus 4. And if you wanted to double check your answer by going through the process this way, right, by double distributing this, you would get back to 3x squared plus 14x. So there are several steps to it, but essentially we're doing this process of double distributing, and we're undoing it when we're factoring, right? We're undoing it to factor to get this. Let's do another example down here. And this one adds just one more thing that we want to do, and it's like you can get the same answer, but it's much more efficient if we factor out a GCF first, right? So before you think about this double distributing process, do what you did up here and try and find a GCF to factor out. So you have 8x squared minus 2x minus 10. The GCF there, I'm going to say, is 2. And so now we want to divide each of these 2x squared minus 2x minus 10. We want to divide each of them by 2. We're going to put that as 4x squared minus x minus 4. And we want to try and factor this. The reason why we want to factor out the GCF first is because at the end, we're going to put this GCF back out in front, and it'll make it so that it's equal to this original one. But in the meantime, we get to deal with a smaller equation, right? We get to deal with a simpler equation. If we're doing this complicated process, we want to make sure we're doing it with the simplest expression possible. Okay, so next, what you're going to do is I want you to label A, B, and C based on the result, based on what you see here. I'm going to say A is 4, B is -1, C is -4. C is -5. Hopefully you guys caught that mistake before I did, but C is -5. And now we've done steps 1 and 2. We're going to go to step 3, and we're going to build our magic X. And for the magic X, what we're going to put on the top is A times C, right? A times C. You want to multiply those two together. So I'm going to put -20 on the top. And on the bottom, we're going to put B, right? Just our B term. And so that is -1. And so now I'm going to look for two numbers, and then multiply to -4 and add to -1. I'm going to say that will be -5 and 4. 4 and -5. Those will multiply to 20 and they will add to -1. And so now we want to split B into two factor pairs, right? That's what the magic X is for. It's kind of undoing this final step here where we combine like terms. We're undoing that, so we're splitting B into two different factor pairs. So we're going to write 4x squared plus 4x minus 5x minus 5. And Importantly, you should be able to see 4x minus 5x is that negative x there. So we took that negative x and we broke it up, right? We expanded it into 4x minus 5x. Okay, now we want to split it up so we're looking at our first two terms and our second two terms. And here, just for clarity, right, you can do this. You don't have to do this, but this is going to make it easier to see what's going on. I'm going to do plus negative 5x and plus negative 5. Right, addition, if you add a negative number, that's the same thing as subtraction. So just changing those subtractions to plus a negative is totally valid. And I'm going to put parentheses around it like that. But remember, I'm still saying that it was this 4 and this negative 5 that are equal to that negative x up there. Okay, so now we've split b, we've put parentheses around the first two terms. Now we're going to factor out the GCF of the first one, we're going to factor out the GCF of the second one. Right, the sets of parentheses, we're going to factor out the GCF here, we're going to factor out the GCF here. What is the GCF between 4x squared and 4x? Well, it's going to be 4x. And what needs to go in the parentheses? X plus 1. So that when we distribute back, we go 4x times x is 4x squared, 4x times 1, that's 4x. What is the GCF between negative 5x and negative 5? Well, that's going to be negative 5. And what needs to go in the parentheses to make sure that that when we distribute, we get back to negative 5x plus negative 5 or 5x minus 5? We need to do x plus 1. And it's really important that you keep track of your signs here, right? If you did x minus 1, that would be incorrect because negative 5 times negative 1 would give you a positive 5, but we know that we want a negative 5. So make sure you're being very careful with your signs. And then our final step is kind of undoing this first step where we broke it up, where we multiplied the second term by 2x and the second term by 3. Right, we're undoing that step. And so we're going to take the 4x minus 5 and put that in one parentheses. And we're going to put x plus 1 in the other parentheses. There you go. That's how you factor. Hopefully that was helpful.